Howdy. Strange ripples have been detected at the edge of the solar system. Michel Starrer. An illustration showing the solar system inside the heliosphere, with the termination shock and heliopause represented by two bubbles, one inside the other. And we might be somewhere here. The bubble of space encasing the solar system might be wrinkled, at least sometimes. Data from spacecraft orbiting Earth has revealed ripple structures in the termination shock and heliopause, shifting regions of space that mark one of the boundaries between the space inside the solar system and what's outside, interstellar space. The results show that it's possible to get a detailed picture of the boundary of the solar system and how it changes over time. This information will help scientists better understand a region of space known as the heliosphere, which pushes out from the Sun and shields the planets in our solar system from cosmic radiation. There are a variety of ways the Sun affects the space around. One of those is the solar wind, a constant supersonic flow of ionized plasma. It blows out past the planets and the Kuiper belt, eventually petering out in the great emptiness between the stars. The point at which this flow falls below the speed at which sound waves can travel through the diffuse interstellar medium is called the termination shock. And the point at which it is no longer strong enough to push back against the very slight pressure of interstellar space is the heliopause. Both Voyager probes have crossed the heliopause and are, effectively, now cruising through interstellar space, providing us the first in situ measurements of this shifting boundary. But there's another tool out in Earth orbit that has been helping scientists map the heliopause since it commenced operations in 2019. NASA's Interstellar Boundary Explorer. IBEX measures energized neutral atoms, which are created when the Sun's solar wind collides with the interstellar wind at the solar system boundary. Some of these atoms are catapulted further out into space, while others are flung back at Earth. Once the strength of the solar wind that produced them is taken into account, energized neutral particles that return our way can be used to map the shape of the boundary. A bit like cosmic echolocation. Previous maps of the structure of the heliosphere have relied on long-scale measures of the evolution of solar wind pressure and energetic neutral atom emissions, which resulted in a smoothing of the boundary in both space and time. But in 2014, over a period of roughly 6 months, the dynamic pressure of the solar wind increased by roughly 50%. A team of scientists led by astrophysicist Eric Zierenstein at Princeton University has used this shorter scale event to obtain more detailed snapshot of the shape of the termination shock and heliopause, and found huge ripples on the scale of tens of astronomical units. One astronomical unit is the average distance between Earth and the Sun. LISM inflow. What is LISM? Don't know, maybe it's coming still to light. They also perform modeling and simulations to determine how this high pressure wind interacted with the solar system boundary. They found that the pressure front reached a termination shock in 2015, sending a pressure wave through the region between the termination shock and the heliopause, known as the inner heliosheath. At the heliopause, a reflected wave travels back, colliding with the still incoming flow of charged plasma behind the pressure front, creating a storm of energetic neutral atoms that fills the inner heliosheath by the time the reflected wave arrives back at the termination shock. The team's measurements also show quite a significant shift in the distance to the heliopause. Voyager 1 crossed the heliopause in 2012 at a distance of 122 astronomical units. In 2016, the team measured that the distance to the heliopause to the direction of Voyager 1 was around 131 astronomical units. At that time, the probe was 136 astronomical units from the Sun, still in interstellar space, but with a ballooning heliosphere behind it. The team's measurement to the heliopause in the direction of Voyager 2 in 2015 is a little trickier. 103 astronomical units with a margin for error of 8 astronomical units on either side. At the time, Voyager 2 was 109 astronomical units from the Sun, which is still within the error margin. It didn't cross the heliopause until 2018 at a distance of 119 astronomical units. Both measurements suggest that the shape of the heliopause changes, and not insignificantly. It is not entirely clear why. Not insignificantly. However, in 2025, a new probe will be sent into space to measure energetic neutral atom emission with higher precision and across a wider energy range. That, the team said, should help answer some of the perplexing questions about the weird invisible wrinkly bubble that protects our little planetary system from the strangeness of space. Back to the local chimney. I figured out I probably should have turned this 108 degrees, 80, not 8, 180, because it probably would fit better. I don't know, but this fits well enough. The Sun is here, within the local chimney. And that's our galaxy. It expands to both directions still. We are in one arm of the galaxy. And as does through Earth, there's a Birkeland current going through Earth's core. So it does going through the Sun's core. The Sun is connected with the Birkeland current to probably the center of our galaxy, and we are connected to the Sun with the Birkeland current. Earth has a magnetosphere, so does the Sun. It's just a little bit differently called, and probably works a little bit different. But the principle is the same. There is a bubble within the bubble, within the bubble, within the bubble. Spheres within spheres, many of them. And if they are wondering why the bubble is wobbling, then you might look at the global temperature record. This is Wikipedia, available for anyone. Thousands of years ago. That's just a shorter term. But you can see the wobbling of the bubble. It's wobbling, sometimes less, sometimes more, but it's wobbling all the time. So there is not too much mystery in that, to me at least. But now let's check out something else too. And that's just the feed I get, you know. The moon may formed instantly from an unknown mass collision. But we won't now read this, maybe we do it later. But there's another one which is just now in the feed, which is very interesting. Slayer. The Slayer album that Kerry King regrets making. Here it comes. Scientists can no longer ignore ancient flooding tales. I read this, it's very short. I cannot reach the article since it's behind money and institutional walls of obscurance. Scientists can no longer ignore ancient flooding tales. Indigenous stories from the end of the last ice age could be more than myth. October 10th, 2022. The story was originally published in the Hakai magazine. It wasn't long after Henry David Inglis arrived on the island of Jersey, just northwest of France, that he heard the old story. Locals eagerly told the 19th century Scottish travel writer how, in the bygone age, their island had been much more substantial, that folks used to walk to the French coast. The only hurdle to their journey was a river, one easily crossed using a short bridge. Pah! Inglis presumably scoffed as he looked out across 22 kilometers of shimmering blue sea between Jersey and the French coast. Because he went on to write in his 1834 book about the region that this was an assertion too ridiculous to merit examination. About 150 years later, another writer, Jean Baudistre, had been similarly unmoved by the tale. No one could have trod from Jersey to Normandy, he withered, unless it were before the flood, referring to the Old Testament cataclysm. Yes, there had been a flood, a big one, between roughly 15,000 and 6,000 years ago. Or maybe 12,000 and 6,000. Massive flooding caused by melting glaciers, hence mountain water, wide rivers and such, raised sea levels around Europe. That flooding in what eventually turned Jersey into an island. Rather than being a ridiculous claim not worthy of examination, perhaps the old story was true. A whisper from the ancients who really did walk through now vanished lands. A whisper that has echoed across millennia. That's exactly what the geographer Patrick Nunn and the historian Margaret Cook at the University of Sunshine Coast in Australia have proposed in a recent paper, which I cannot reach. In their work, the pair describe colorful legends from northern Europe and Australia that depict rising waters, peninsulas becoming islands, and receding coastlines during the period of deglaciation thousands of years ago. Some of the stories, the researchers say, captured historical sea level rise that actually happened, often several thousand years ago. For scholars of oral history, that makes them geomyths. The first time I read an Aboriginal story from Australia that seemed to recall the rise of sea levels after the last ice age, I thought, no, I don't think this is correct, Nunn says. But then I read another story that recalled the same thing. Nunn has since gathered 32 groups of stories from indigenous communities around the coast of Australia that seem to refer to geological changes along shorelines. Take the legend of Garngoor, told by the Lardil people, also known as Gunhanana in the Wellesale Islands. Yeah, I probably butchered all of those words. Of northern Australia. It describes a seagull woman, Garngoor, who cut the islands off from the mainland by dragging a giant raft, or walpa, back and forth across the peninsula. So maybe we could assume it was a thunderbird after all, and the raft was a lightning strike, a thunderbolt, maybe, I don't know. In some versions of the story, this is punishment for her brother Crane, who failed to look after her child when asked. So this might refer to the polar configuration. There might be Venus involved in this story as well. Nunn and Cook argued that the narrative can be taken as a memory of how, roughly 10,000 years ago, melting glaciers caused the Welisey Islands to be cut off from the mainland. Interestingly, there is an underwater ridge between two of the Welisey Islands, perhaps a feature of that seabed that prompted the image of Gardengur plowing her raft into the earth, the researchers suggest in their paper. Separately, other indigenous groups in South Australia, such as the Ngarrindjeri and the Ramdieri, tell of a period when Kangaroo Island was once connected to the mainland. Some say it got cut off by a big storm, while others describe a line of partially submerged boulders that once allowed people to cross the island. To the island. For Jo Brendruyen, a paleoclimatologist at the University of Bergen in Norway, who has studied the effects of glaciation in Europe following the end of the last ice age, the idea that traditional oral histories preserve real accounts of sea level rise is perfectly plausible. During the last ice age, he says, the sudden melting of ice sheets induced catastrophic events known as meltwater pulses, which caused sudden and extreme sea level rise. Along some coastlines in Europe, the ocean may have risen as much as 10 meters in just 200 years. At such a place, it would have been noticeable to people across just a few human generations. The stories are anecdotes, but enough anecdotes makes for data. These stories are anecdotes, but enough anecdotes makes for data. Everyone who hasn't heard about Emanuel Velikovsky or David Talbot, the polar configuration. These stories are anecdotes, but enough anecdotes makes for data. Take this. Brendruyen explains. By systematically collecting these kinds of memories or stories, I think you can learn something. Anthony Peratt, plasma petroglyphs. Interdisciplinary science. Beyond capturing historical events, geomyths offer a glimpse into the inner lives of those who were there, says Tim Burbury, an expert on geomyths from Marshall University in West Virginia, who was not involved in the research. These are stories based on trauma, based on catastrophe. Emanuel Velikovsky. He was a psychoanalyst. Yes, now also mainstream comes to the same conclusions. Boom! That's something really interesting. But now to something also interesting, maybe. Earthquakes. 2.4, 17 hours ago. Joensuu. Check it out. Place of the plasma rocks. It's not often there's so close an earthquake. Tohmajärvi. And there is, of course, water and all kinds of stuff here. Swamps, Suomi. Finland in Finnish is Suomi. And suo means swamp, peatlands. And I know this region to some extent, since I live here and stuff. And there is fishing grounds here. Let's see if I can find it. No, it's very small. Ruskealankoski, Peltokoski. Ruskeakoski. There is a dam. And then there's a gorge. First it's channeled and then it makes a turn. You can leave your car here or somewhere. Here's the parking place. And that's a very nice spot to fish. I couldn't find any pictures I would have shown, but anyway, Ruskeakoski. Geology of Finland, Wikipedia. There's a map. Map showing the large-scale geological units of Finland. The Scandinavian Caledonides are shown in green. The Kola domain, Lapland granulite belt, and inner ring complex can be seen in blue. The Karelian domain is orange, while the Svekofenian origin is shown in violet. Areas younger than the Svekofenian origin, chiefly Rapakivi granite and Jotnian sediments, are in white. But we are here, in very old rock. And over time, the shape of Finland has changed due to political influences. It shrank and grew and shrank and grew. Fluctuations. But anyway, Ruskeakoski. That's unfinished ground. And somewhere down here, it's very hard to find since I'm not very sure where it might be. Wärtsilä. Yeah, it's very hard to find if you don't know exactly where it is. But I think I found it on Google Earth, so then I don't have to search for it anymore. So we have been here somewhere, and now we go to this place, which has the same name, Ruskeala. There we can find this. That's an old marble mine. And marble is the vitrified version of limestone. That's massive. Nowadays it's filled with water, obviously. But not only do we have a marble quarry, stone has been quarried from Ruskeala for buildings and churches since the 18th century. For example, Ruskeala marble has been used in Marble Palace of St. Petersburg, floors of the Kazan Church, Isaac's Church, the Winter Palace, and the Hermitage. In Helsinki, the same marble has been used, for example, in the former office of Yleisradio, on the edge of Kasarminator. Kasarm. I think this is translated wrongly. And in the buildings of Säästöpankki, Zacharias Topelius described it in his book Old Beautiful Finland, published in 1845. As follows: Ruskeala marble is sometimes ash gray with yellow or greenish streaks. Sometimes it is greenish with white and black stripes. Sometimes it is white, gray, and black, and sometimes brown and gray. Well, what a description. And I found out about this mining operation there when I was going through this paper or book. I think it's a book. Steinbruchindustrie und Steinbruchgeologie. Dr. O. Herrman. Made in 1899. And then we scroll down to page 93. Where was it? No, it's not this page actually. It's on the next one. Here. Very interesting. I didn't knew that there is a marble stuff here because it's supposed to be one of the world's oldest rock formation, but it is not. It is just like electrically altered much more than others. So it stays interesting. I leave it here. Thanks. Bye.